But as you can see, the kernel has successfully run, so we have the 8 execution. Excellent. And lastly, we are going to add another markdown code for get information from Alana. There you go. Here executed. There you go. We have like this structured steps in order to get access and get the information we seek from Alana. We're going to the object that we instanced a couple of minutes ago. We as you can see, we have several functions here. We're going to use, for example, this get field master in order to see the fields that are stored in the server. The response we have from the server, it's a list of dictionaries, which in this case we only have one element, one dictionary that has the ID, the field name, in this case bold, where when this element was created, if it has been updated, any comments, the country where it's located, the basin, the block, and the scope. As you can see, we can add several information, several useful information regarding this item. Of course, we can keep building. We can keep adding new IDs. We can keep adding new field names. But this is with the sole purpose of we uploaded this open source open data of both. Then we are going to add here as a variable response, which is this is our response from the server field. There you go. Excellent. There you go. We can actually, in order for this to be kind of explanatory, we are going to give me just 1 second, bear with me. There you go. Response field, the element 0, it's this. And if we keep kind of accessing the data contained in this object or in this dictionary, we can keep field there's something icky here. There you go. Field name. And there you go. We have the both field ID as well as the field name. What else can we access? I mean, this is an introductory session, live coded. We're going to instead of response, let me show you. We're going to call a function get well master in order for you guys to see that the response in this case, instead of being the field master, we are getting the IDs and the well names and several information of each well that is contained in the server, in memory in the Alana server. In this case, we have the well name, the spot date, the production date. We can have as well API code, latitude, longitude, the UTM in X and Y, any comments, the type of well that it is, the field FK. Remember that we are talking about relational databases. So in this case, the field FK, or the foreign key of the field, is the bold field, which is we saw here. It was, let me put it as a list, as a zip, for you guys to see it much more clearly. List. Then we are going to create a zip object, and we are going to add the, instead of the field name, we are going to add the ID. There you go. Open, close here, and it's not iterable. Interesting. List the zip. Maybe I'm doing this the wrong way. Let me check it. There you go. It's of course, yes. We're going to add a string. We're going to convert this element into string, and there you go. Field name. Interesting. I don't know why this is happening. Field 0 ID. Let me check. This element should be properly stable. There you go. And this field name, what happened? Maybe it's because I cannot. There you go. I don't know why it's doing this, but I mean we can add the print. There you go. Unmatched. Yes. There you go. For example, we have the bulb and the ID 1, right? Which is the only ID that is available right now in the open server, which corresponds with this field fk, of course. You can see here formation fk. We can actually, if we upload several wells, maybe those wells are commingled, have commingled production. So a formation indicator or a flag for any formation in the field, it's quite useful. So, but in this case, the bulb field goes with the hook information, so that's the only formation available in this server. Then again, we can create a variable called response wells. We can, there you go, declare it as this. But okay, excellent. What else can we do with the data that is coming from the server? Well, we can create using the tools given us by Python. We can create a data frame with the response wells variable. Let's see how it looks. There you go. We have the data frame regarding this variable. We can keep adding new things to it, so we can keep let's remember that this can get complex and complex the much more we decided to be or as well the project requires. I'm going to create for the to use a bit in a couple of minutes. I'm going to create a dictionary from this data frame, because I'm going to use it because as we are talking about fields IDs, we're talking about wells and its ID in the database. I'm going to create an object from this df wells, but this is going to be only with two columns, the ID and the well name. There you go. We are going to set the index with a well name for us to have as keys the well names and values its IDs, and then we are going to create the dictionary. Let's see how it looks. df wells, of course I misplaced an s here. There you go. And as we can see, we have a key ID, so we're going to access this key to get the result dictionary, which is this. There you go. I'm going to store this as a variable dict wells. There you go. I'm going to call it again for you guys to see it. Dict wells. There you go. Excellent. I'm going to create a function as well, which will be able to, if we pass to the function its name, we need to have in return its value. So let us call this function get value from dict. There you go. The arguments of this is going to be the key and a dictionary. Dict. There you go. Two dots. There you go. We're going to return. Let's delete this, and we are going to access the dict and the element or the key, and that's the return of this. Let's just taste it just for the sake of this, to avoid any issues in the upcoming executions of the kernel. We're going to add this key and the dict, which is dict wells, and there you go. We passed the 1_c, and we got in response this 1 ID. Let's test it with this F5. Execute it, and we have the 7th key, the 7th ID of with this well. Okay, excellent. So what else can we do? What else is available to us in the Alana API script? Well, there are several things there. There are several functions, and in this time we're going to check my API dot get monthly production. The get monthly production is fed with IDs, with the well IDs that we need to request the monthly production to the server. In this case, for example, we're going to request the 7th ID, and there you go. We have in response the date or the production profile, the production data of this specific ID, well ID. We have date, we have oil rate, we have water rate, gas, if the well has any injection rate, any gas, maybe steam. This depends on the production or injection profile of the wells that we have uploaded to the server. We can as well have several metrics: gas oil ratio, water cut, water oil ratio, and so on and so forth. And this we can store it. Let's remember that we have this object. This is a JSON object that comes from the server. So we have key data. So in order to access the elements inside this, we need to call the key, right? So we're going to add a new variable called response production equals this, and we are going to, there you go, it's requesting, we have it. We are going to, in order to avoid any other request to the server, it's already stored. We are going to create a data frame, the df production, equals pd.dataframe, and here we are going to pass the response production. Let's see, let's print it. We are going to print only the head, the first couple of rows for the head. As I said previously, this can get complex. Just depend on the workflow that we are managing, the workflow we are going to need, the data we need, and so on and so forth. There you go. We have dates, we have water rates, we have gas rates, we have cumulatives, we have other metrics. Let's see the df production, and we can access we can get the series date and ask Python for its minimum value. There we go. The production started on 2007. But what happens if I want to see, for example, the maximum, the last date of production? There you go. We have 2017, 16, sorry. We can use built-in properties, built-in methods of Python. We can ask for the types. There we go. We have objects. We can turn this into datetime in order to plot properly. We have integers. We have floats and so on. In this case, we're going to make a very neat notebook. We are going to use from IPyWidgets. We're going to create a drop down that will kind of for us to select a well. We are going to pass plot the well, and we shall kind of request that well to the server, return it and plot it. It's oil, the oil rate and the cumulative of oil, and maybe gas. So let's call IPyWidgets as widgets, and we are going to this is my mistake, this shall be import. This is a library, and from this we are going to import as well IPyWidgets. We are going to import interact, which is quite useful. Interact. Let's see, there you go, no issues here. We are going to create a well name list from the dict wells, its keys. There you go, but this is not a list. This is not a list, so we need to specify that is a list data type, as well as the well ID list, which is the instead of keys, it's the values of this dictionary. There you go, the equals values. There you go. I know that. There you go. Excellent. So we are going to create an object. Let's call it W, which is going to be from widgets dot drop down. Is it dot drop down? There you go. Drop down. And let's see, let's check for the doc strings. Yeah, I forgot to tell you guys. This Alana API, this script has several functions. We've used a couple of them in this notebook. We are keep, as I told you, we are keep updating the script. We are adding the doc strings to each of the functions, stored in that for you guys to see it much more clearly. But as I said, this is a work in progress. If for example you are if you have any request to it, if you want to access it, of course you need to request either Alejandro or me, to have like this quality control. We are going to keep updating it to add much more features to it, as I said. So the drop down, I know that the doctrine says that we need a value, a label, description, and so on and so forth. I'm going to add options are going to be the well-named list that I previously declared. Let's go down. There you go. I'm going to need as well, or this drop-down function requires a value, which is going to be kind of the first value shown in the drop-down. So I'm going to use the well name list, the indexed 0, the first element of this list. and we're going to add as well a description or a kind of a label that it's going to be shown in the drop down, and this is going to be well name. Well, no, it's not going to have an underscore, but 2 dots. There you go. And I think that's looks promising, and we are going to display this element, W element. Let's see, there you go. We have well name, the description, and the list of wells. We, for example, I've selected the F14. In order to get this value, we access the object and its value. There you go. We have a string with this element that we selected, and we can keep adding complexity to the workflow. And we previously created the get value from dict. So if I know that the well name comes from the W value, and the dict is dict well name wells. There you go. This well corresponds with this key, this F4. It's going to be changed here. There you go. And if we update this, well, this is the 6th ID in the dictionary that we did. Okay, so there you go. What else can we do? Well, we are going to create a function. Just bear with me. This display well production, and we are going to call it like that. This function is going to have well name. We are going to pass on this this drop down well name. There you go. We're going to add as well a fluid. Either is gas. Let's put it with gas or oil, and there you go. Okay, excellent. Let's review. Let's remember that the monthly production, we need to pass in the arguments the well ID. So I need to change this well name into a well ID, a valid argument for the API. So we need a well ID, which is going to be the get value from dict. This get value from dict function, we are going to pass on the well name, and it's going to look for this key in the dict wells. It's going to have the well ID now. We're going to have that well ID, and we need to send this to the server. So we're going to use the object my API dot get monthly production, and its well ID, its argument. Excellent. We're going to create the data frame, an internal data frame in this function. Data frame df, it's going to be pd pandas data frame function, and the response we saw that comes in the form of a dictionary, so we need to access the data. There we go. Excellent. What else? We might need dates. The dates of this data frame, we're going to change those to daytime. So we're going to use we're going to create a new list, a new variable called new date, which is going to be pd to daytime from the series date, df date. Excellent. I type incorrectly here. Okay, excellent. What else can we need? Of course, and there you go. We have going to create a figure and an X of subplots. There you go. We are Bear with me, guys. This is a kind of a complex function. Well, it's not that complex function, but just bear with me. We're going to test it, and we're going to get it. We're going to get it working. Okay, so we're going to add title as well, which is going to be the string well name. Let's keep it on lower cases, 2 dots, and here inside this we're going to pass the well name variable. There you go. There you go. Excellent. We need as well, as we're talking about two fluids, we can have a variable called while label, which is going to be oil rate. While label for whom, for the cumulatives, is going to be oil. These are the labels. These shouldn't have any underscore. Sorry for that. Oil cum cumulative. This is going to be the labels on each axis. There you go. And this is where column for rate, the column in data frame. I know that this. Let's review it. It's oil rate and gas, and water rate and gas rate. Let's keep that in mind, which we can access the dot columns, but just for the sake of this exercise, we're going to use this form, this kind of, in order for us to see the name of the columns. It's going to be column rate, oil rate, the column for the cumulative is going to be called like this, and it's linked with the oil column of the data frame that we're using. We're going to add a color. It's going to be colors, and it's going to be, we're talking about oil, so it's black. For if we pass instead of the string oil in the fluid variable, we are going to add if fluid equals gas. There's something's going to change. This is going to change this variables, but instead of kind of typing it, let's change it all at once. I know that if I press Ctrl, we can change multiple rows, and it's going to be gas rate, gas cumulative, and so on. We're going to, just for the sake of styling, we're going to add the appropriate while labels, and here we are going to standardize it as a red, with a red color. We are going to create the axis. In this case, x1 is going to be set x label. It's going to be the x label is dates. There you go. x1 dot set y label. It's going to be the y axis, and in this case the first axis, it's going to be the y label, the variable that we previously declared. There you go. And we are going to add the color that we decided, which is going to be stored in colors variable. There you go. We can now add what happened here. x1 dot plot. We're going to plot the series new date, which is here. It's the datetime of this column, new date, comma and the data frame column, which is the column rate, because we are in the first axis, and we are adding the colors equal color. Yeah, that's the argument. Let's review it. Do we have docstring for this axis? No, we don't have any docstring. So yeah, I remember it's color. So we have colors stored here. And we are going to then the second axis, which is going to share the x-axis. So it's going to be axis 1 dot twin x. Excellent. The axis 2 dot set. Let's copy this. Y label instead of axis 1, axis 2. Set y label. Y label underscore cum. It's color. Excellent. And the plot. Lastly, the plot command for this axis. Axis 2, new date. Instead of column rate, we are going to plot the series stored on the column cum. There you go. And the color, the appropriate color. Excellent. I think that this is fine as it is. Let's test it. Sorry. We need to pass on w.value, and it's the fluid is predefined as oil, and there you go. We have a response. In this case, we don't have any oil rate in this well, so most likely it's an injection well. Okay, so let's change the well. F11. Let's review that successfully changed. There you go. Let's review the ID. This is the second ID, and we pass on the well name, and there you go. We have yes, there's something we need to change here. The well name F11, and this is the production profile for this well. I'm going to add, instead of for the cumulative, we are going to add another parameter or argument, the line style. The line style is going to be 2 dots, two lines. There you go. Excellent. That looks quite nice. Excellent. So what happens if instead of oil I type gas? There you go. We have gas rate and gas cumulative. Excellent. But there's something funny happening in these dates. So maybe the labels are quite large. So I'm going to add here another kind of line of code that goes with the tick params. The tick params will kind of shift or tilt the axis labels. In this case, I'm going to tilt the x-axis, and I'm going to rotate it 45 degrees. Let's see. And there you go. Excellent. It looks quite nice. Instead of gas, oil. There you go. And we have our function that plots oil cumulative, oil rate, the well name. I'm going to use, I said that we are going to use the interact function. This is quite a very simple dashboard, a very simple workflow, but I think that you're getting the idea of the excellent or the big power that this can representing working in any project. Aside of this is not the only module. This is not the only class, the data source class. We have DCA, the DCA class, the well typing class, the economic class. But this is going to be we are going to keep evolving. We are going to keep advancing, and Alana is growing each day. So we are going to interact. We are going to use the interact function, and we need to the arguments of this interact is a function that displays something. In this case, display well production. We need to pass on as well a list. Well name. It's going to be the well name list. And a list of fluids. In this case, fluid equals, we only have two fluids. In this case, either it is gas or oil. So I'm going to two elements in this list. It's either oil or gas. Let's run it, and there you go. We have successfully placed this drop down, and as you can see, it's requesting dynamically to the Alana server and plotting the results. We can change it for gas. This is the gas production for this F14 well. Let's check out the F12, and there you go. It has requested successfully with the API the production profile of this well. Let's change it to oil, and there you go. So I think that you guys can see the power of this kind of workflows. We can keep adding complex elements to it, complex workflows, complex functions as well. We can keep adding new features to the Alana API if we want to get any other information. Later on, we are going to keep posting this kind of. You guys need to remember that in the top right corner of the Alana app, you guys have access to the workbook. In the workbook, we have several examples in how to use the Alana API, the Alana script. So I think that this would be the last my last part. So I think that you can continue with the rest, Alejandro. Thank you very much, and thank you guys of bearing with me in this live code example. Thank you.